This is second day. So section 3.7 part B for today. So section 3.7 part B, optimization. So yesterday I gave you guys an example with a box, trying to maximize the volume of a box, and we found that the volume or the dimensions of that box should be a 6 by 6 by 3. So what we're going to do today is kind of talk about like maybe maximize or optimizing our distance. Okay, maybe minimizing it, maybe maximizing it, depending on what it is. So here's example 2. Let me write it out. So example number 2 says which points on the graph. So which point on the graph of y equal to negative x squared plus 4 are closest to the point zero comma 2. So which point on the graph of y equal to negative x squared plus 4, or maybe points, are closest to the point 0, 2? Now just to draw a picture here. So we have 1, 2, 3, 4, 1, 2, 3, 4. So just kind of going around making a square graph of 4s. We know that negative x squared plus 4 should be a parabola opening down, starting at 4. Okay, and its x-intercepts will be plus or minus radical 2, so that's going to be around here. Okay, so there's your graph for this thing. Now they're saying that they want to know which point on this graph is closest to 0, 2. Okay, so that green point right there, which one is closest to that? Actually, what am I talking about? I'm wrong on my graph. Hold on. I did that incorrectly. Give me a second. I just realized that when I took my square root of 4, I should have gotten 2, not the square root of 2. So my apologies for that. So plus or minus 2. In order to figure out the x-intercepts, remember you just set y equal to 0, so y is equal to negative x squared plus 4. If you move the x squared over, you get x squared equals 4, so 2 or negative 2 should give you that answer. And still, 0, 2 is my point of reference, so right here. I want to know which point is closest. So like, for example, will it be this point here that the distance from here to here is going to be shortest, or will it be this point here, right? Or maybe it's this point right here that the distance is shortest, right? I mean, I'm not sure, but we could figure that out. Okay, so that's the main idea that we're trying to do. Which point on this graph, or maybe points, are closest to that green point? Okay, so in optimizing, we're actually trying to minimize what? What am I trying to minimize? When they ask me which point is closest, what am I minimizing? Distance, right? And we know a formula for distance, right? So we know that distance is equal to the square root of, notice I did put the letter S for distance, not the letter D, because if you take the derivative of distance, you don't want it to be dd, right? D something, right? It's going to look really weird. So we use S. So S is equal to x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So there's one formula I know. Is there another formula I know based on the problem? Did they give me any other equations? I'm not sure if you're thinking, is that what he's talking about? But they straight out gave me that one, right? Y is equal to 4 minus x squared, or negative x squared minus 4. So I'm going to write that down. Sometimes the obvious stuff is the stuff we missed. I know that when I was first learning these types of problems, I would always forget that they gave me the equation to begin with. So that should be pretty important. All right, so my objective is to minimize distance. That means I'm going to have to take a derivative of distance. Okay? So when I take the derivative of distance, I mean, you can see that there's 3 main variables, a whole bunch of different ones, right? But there's 3 main variables. So what can I do? Well, they give me a specific point, 0, 2, so why don't I use that right now? So let me plug that in. S is equal to the square root of, instead of x sub 2, I'm just going to call it x minus 0 squared, because, I mean, I'm plugging in a 0, so there's no reason why my x sub 1 and x sub 2 have to remain with the subscript, because there is no other x anymore. And then my y sub 2 would just become y minus 2 squared. So if I can simplify that a little bit, s is equal to the square root of x squared plus y minus 2 squared. So hopefully you guys are still okay with this. Okay, we're just basically simplifying after I plugged in the 0.02. Now I put it in because that's the point that I want it to be closest to. So I'm going to include it in my problem so that it's using that value as like its center of thinking, right? It's thinking like, this is the point that I need to be in reference with. So I'm putting it in. Now, you want to take a derivative of s, but we still have 3 variables, right? So this is where that other equation comes into play, because that other equation can be plugged in right there. And when I do that, then everything is in terms of s's and x's, right? So let's go ahead and plug that in. S is equal to x squared plus negative x squared plus 4 minus 2 squared. And I'm going to simplify this. Okay, so s is equal to the square root of x squared plus, well, let me see. This would have been a negative x squared and 4 minus 2, that's a 2. So that is that, okay? Just so you know, 2 minus x squared is the same as negative x squared plus 4 minus 2. So that way when I square it, I should get a 4 minus 4x squared plus x to the 4th. Okay, so when I figure that out, that's what I get. So let me just simplify that a little bit more, and then we'll move on. So we have x to the 4th, and then x squared minus 4x squared, that's negative 3x squared, and then a 4. So I'll stop right here. Are we good? Notice I haven't done any calculus, okay? I know I say that a lot, but I just want you guys to understand that we haven't done anything calculus related yet. Okay, we're about to, but we haven't done anything calculus related yet. So, in order to find the point closest, I need to optimize distance, right? I want to minimize it. And in order to find minimums, we would take derivatives and set them equal to 0. So that's what I'm going to do. I'm going to take a derivative and set it equal to 0. So ds dx. Now I'm going to rewrite this just so you guys can see it. I'm going to put it in green. But I'm just going to rewrite it with the power. Okay, so when I take my derivative, you understand where the half came from. So half x to the fourth minus 3x squared plus 4 to the negative half, because I have to subtract 1 from it. Notice I didn't take a derivative of the inside yet. Remember, you always do the power first. You ignore what's on the inside, just rewrite it. And then multiply by the derivative of the inside. So that would be 4x cubed minus 6x. And that's my derivative of that portion. Now let me rewrite it because, of course, I got to set it equal to 0. So I have, I'm going to put half times on the top 4x cubed minus 6x over x to the fourth minus 3x squared plus 4, and that's a square root. Because that's the negative half power. Now, if I'm going to set this stuff equal to 0 or undefined, right? 0 or undefined. Let me write something out really quick. Okay? So let me see. Why is it making me do that? Browser ROM. There it is. Open that. All right. So let me. What was the function that we had? Let me put y equals to here. It was the square root of, and then x to the fourth. Was it minus 3x squared? Okay, minus 3x squared, then plus 4. All right. Let me graph that. All right. So why am I doing this? Well, I'm going to have to set the derivative equal to 0, and I'm going to have to set the derivative to undefined. What makes it equal 0? What makes it undefined? Now, to make it equal 0, I'm going to have to set the numerator equal to 0, right? That's how you set things equal to 0. You get the numerator, you set it equal to 0. To make it undefined, I have to set the denominator equal to 0. Okay? And then I graphed it, and I look to see where the denominator crosses the x-axis. Where does it cross the x-axis? Can you guys tell? Let me zoom in a bit. I'm going to zoom in right in the middle. Does it cross the x-axis? No. So are there any solutions for the denominator of my derivative? Is there anything that makes the derivative equal to 0? No. Right? So then all I have to worry about is my numerator. Okay? So just a real quick mention here. If you were to graph it, I'm just going to put a little picture here. It looks like that. It does not cross the x-axis, therefore it has no solutions, no zeros. It has no zeros. Okay? So I don't have to worry about the denominator, but I do have to worry about the numerator. So let's set the numerator equal to 0. Does everybody understand that part of using a graph of the function to check to see if there's any solutions? Okay. Now notice right here, I could easily just solve this by factoring and stuff like that. But if you don't want to, but I do recommend doing it that way. But if you don't want to, you can go back to your graphing calculator. Okay. Go to your y function. Let me erase this whole thing here. Remind me what the equation was. Was it 4x cubed minus what? 6x. Okay. And I'm going to graph it. How many solutions am I going to have? There's one here, right? Can you guys see it? right there. 1, 1 at 0, 0, and 1 right there. So I have 3 answers. And you can have your calculator do that for you. Okay, your calculator could tell you what the zeros are. Okay, if you don't want to factor. All right, of course, if you want to factor it, then let's do that. But you can have your calculator do all this work for you. That's one of the reasons why I want you guys to get one, because it can save you some time. But in our case, we're going to take out a 2x. That'll leave us with the 2x squared minus 3 equals 0. So 2x is equal to 0, or 2x squared minus 3 is equal to 0. So either x equals 0, or 2x squared equals 3, x squared is 3/2, or x is plus or minus radical 3 over 2. Notice 3 different solutions. Right? So I have 3 different answers. Okay? So, let's see. 3 different answers. Let me write this down here. I'm just going to do this for a point, the sake of having points, okay? So I have an xy here. I have a 0, a negative radical 3 over 2, and a radical 3 over 2. Now I want to figure out where the points are, okay? I want to figure out where the points are. So, if I plug in a 0 into my y function, okay, my original y function, which is y equals negative x squared plus 4, if I plug in a 0, I get 4. Okay? If I plug in a, let's say, radical 3 over 2, so that'd be y equals negative radical 3 over 2 squared plus 4, that's going to give me a negative 3/2 plus 4, which is 2.5. So it's 2.5, 2.5. Okay? So let's go back and let's just kind of graph these really quick. I'm going to go back up to the picture. I'm going to graph them. So 0, 4, that's up here. I'm just going to put like a highlighted portion right there. Okay, that's 0, 4. But then the other one is at radical 3 over 2, comma 2.5. So that's like right here. Oops, sorry about that. And the other one is over here. Which points look like they would be closer? The 0 or the rad 3 over 2 or the negative rad 3 over 2? Which ones look closer? If you had to kind of look at the picture. Is it the highlighted ones in yellow or the highlighted ones in blue? Any guess? Come on, somebody guess. I know you know. Which ones? The blue ones. How can I prove it though? All right. Well, don't I have a formula that'll tell me what the distance is? Right? So if I wanted to prove it, now I'm going to tell you that the answer is x equal to plus or minus radical 3 over 2, comma 5 over 2. That's our answer. So let me write this down really quick. Now let me write this down. The minimum distance occurs at plus or minus rad 3 over 2, comma 5 over 2. Okay? Now I did that using the eyeball test. Usually you can't do that on an AP exam. Say like, what's the answer? You're like, well, this. Why? Because I used my eyeball. And I use the eyeball test, right? Yeah, it just makes sense, right? No, you got to prove it. So the way you're going to prove it is you're going to do the following. You're going to take the distance formula between the points 0, 4, 4 and 0, 2. Okay, you're going to do the distance formula between, what was it? Radical 3 over 2, comma, 5 over 2, and 0, 2. So let's do that. Now here's the formula for it. So between those 2 points, the difference between the x's is 0 minus 0 squared, plus the difference between the y's would be 2 squared. So that answers 2. Okay, remember it's x2 minus x1. That's the first part. So 0 minus 0 squared. And the other one is 4 minus 2 squared, right? So 2 squared is 4. Square root of that is 2. Now let's do the other one. So the x's is going to be radical 3 over 2 minus 0 squared plus 5 over 2 minus 2 squared. Well, that's 3 over 2 plus 5 over 2 minus 2, that's a half. Half squared is a 1/4. Okay, so if we add that stuff together, what do we get? That'd be 2, 6, 7 over 4. What's the square root of 7 over 4? Let's see. Let's turn this thing on. Is it on? Not on. Give me a second. I don't know why it's not on. All right, so square root of 7 over 4, 1.323. So 1.323. Now, if you use the negative x value, it's going to be the same distance. You guys get that, right? It's the metric. So which one has the shorter distance? Right? So that's how I know. I can't just eyeball it. I got to prove it. Okay? So I got to show the work. So when we're doing this type of problem, let me just kind of zoom out so you can see, right? I mean, you can obviously see it in your own work. I can't even zoom out enough to show the whole problem. But there it is. Okay. Now, I just want to walk through it really quick. So we were given a problem where they said that they want us to figure out which point on that graph is closest to 0, 2. So based on what they told me, I have one equation of y equals to negative x squared plus 4, and another equation that I have to figure out. They tell you what equation to use, but they're just not like putting it in front of your face. They're saying we need something to be close. Well, how do we measure closeness, right? Well, that's a distance, right? So, okay, so they want distance. So I wrote down a distance formula. I wrote down my original equation. Now, a key to this problem is plugging in the 0, 2. Okay, and a lot of times people forget to do stuff like that. But the reason why we plug in the 0, 2 is because we're centered on that point. We're saying I got to get close to that point, 0, 2. So I got to make sure I use it in my equation. So that can be my centered point. I want this to be my main point. So I plug it in. I'm here right now. Once I plug it in, that's what I get in terms of my simplified equation. But hey, I got to figure out closest to, right? I got to minimize my distance. So in order to do that, I got to take a derivative. But if I'm going to take a derivative, I can't have 3 variables. So I need to eliminate one of these variables, s, x, or y, right? Preferably not s, because that's what you got to take a derivative of, but maybe x or y. But they did tell me that y is equal to negative x squared, so let's plug that in. right? So that's the next step. Once I plug it in, I simplify and I get to that green equation eventually, right? S equals to that green equation. So I say, okay, let's take a derivative of it. So we did. And once we took a derivative of that function, we ended up with this piece right there. And I know it looks really complicated, and I tell you, okay, now set that equal to 0, and you're going to say, well, how the heck do I do that? Remember, to set it, the derivatives, if you're trying to find maximums and minimums, you do it two ways. One way is by figuring out what makes it 0. The second way is by figuring out what makes it undefined. To figure out what makes it 0, it's just the numerator. Get the top, set it equal to 0. That's what I did, okay, on the bottom. The bottom part, you got to do the same thing. Set it equal to 0, okay? But instead of me racking my brain and trying to figure out what does it, I used my calculator. And I said, you know what? Looking at the graph for that function, it does not cross the x-axis. Therefore, there is no solutions to it. There's no way I can set that equal to 0. Okay? So great. I didn't have to do the bottom part, but I did do the top part. Now, in solving the top part, I factored. I got my x values. Okay, and once I got my x values, I right away went into what are the points. Now, if you're wondering, why am I going to do that? How am I going to know to do that? Remember, the original question says, what point? Right? What point is closest to 0, 2? So I'm going to need points. So I figured I might as well do them now. Right? It's nothing, it's not hidden. This is not hidden information. They literally tell you to do that in the first two words. Which point, or points in our case, right? So you're going to need to do that. So I got my 0, negative rad 3 over 2, positive rad 3 over 2, plugged them into my equation that they want me to use for the quadratic function, and I got my points. Now, I right away said, oh, well, I know what my answer is. It's plus or minus rad 3 over 2, 5/2. Why? Because I can see it. I can tell. But on the AP test, you can't do that. Right? You got to show them. Not just like, hey, just trust me. Right? So you have to show them. How do you show them? You use the formula. Okay? Use the distance formula to prove to them that the 0.04 is further away than the point rad 3 over 2. Now, I never tested negative rad 3 over 2, but because parabolas are symmetric, right? So rad 3 over 2, negative rad 3 over 2, they're going to be the same distance. So that's why I didn't have to show the other one. If you want to, go ahead. You're going to find the same answer. Okay, but it's not necessary. So questions on this one? Any questions? I know it's a long problem. Related rates can be long problems. Okay? And I know these aren't like super easy, but I'm hoping at least you can see like, okay, what he's doing, it's in the problem. Everything I've done, all the equations I used, figuring out the points, it's all asked of me. Even though it was just one sentence, it was all asked of me. They said closeness, so that's distance. They wanted me to find closest, that means I got to take a derivative. They told me which point, that's why I figured out points. Okay, how did he figure out the distance between the 2 points? Use the distance formula, right? There's a lot of algebra. There is some calculus that we had to do, but there's also a lot of algebra that we just do that we have to remember. We have to recall it, okay? That we just have to kind of work with it. It's not, this stuff right here at the very end, that's not supposed to be the part that breaks you, okay? Hopefully none of this breaks you, but if anything's going to break you, it's this stuff up here, okay? That derivative portion. That's the part where you might mess up. They're hoping that the algebra stuff, you got it, no problem, okay? It's the derivative stuff that they're saying, okay, they may struggle here. But the rest of the stuff, they should be good. If they can get past the derivative portion, they should be good with the rest of it. Okay? And I know some people tell me, like, even in my fourth period, they'll be like, oh, man, it's always the algebra. I always mess up on the algebra. But remember, that's not supposed to be the part. But unfortunately, that's kind of sometimes where it happens. Right? We forget how to factor something. But yeah, a lot of times it is the algebra that messes it all up. It's not really the calculus. So So again, any questions before I move on? So yeah, big problem, obviously, but hopefully hopefully after you look at it again, maybe you're like, okay, makes sense, I get it, and we move on. So all right, we're gonna start another one. I don't know if we're gonna finish it, but we're gonna at least try to get it started. Okay, so that was a good 30 minutes on explaining one problem. So we're gonna minimize area here. Okay, so let's see, and I'll draw a picture to kind of help out. A rectangular page is to contain 24 square inches of print. Okay, the margins at the top and bottom so the margins at the top and bottom of the page are each 1.5 inches, so 1.5 inches. The margins on each side are 1 inch. Okay, so on each side, they're 1 inch. Here's the question. What should the dimensions be? Dimensions of the page, shall I say. What should the dimensions, I gotta write that right. The dimensions of the page be to get the least amount of paper used? So you have a rectangular page that's going to contain 24 square inches of print. So they're only going to print on 24 square inches of a piece of paper. Okay, now think about it. If you're only going to, if you got an 8.5 by 11 piece of paper, let's say, and they tell you to print on it so that you get 24 square inches, you can say, oh, I'm going to make it a 4 by 6 rectangle, or I'm going to make it a 3 by 8. Okay, so you have a couple of options, right? You can do anything in between, 5 by something, right, to make it 24 square inches of print inside the piece of paper. The margins must be 1.5 on top and bottom and 1 inch on left and right, but you can move it around however you'd like. Okay, but they're saying, okay, if you're given this information, what should the dimensions of the page be so that you could get the least amount of paper used? The whole page. Okay, the amount or what's the size of the whole page? So let me give you guys a picture here. Okay, so they're going to give us a piece of paper. And then within this piece of paper, they want us to have another little bit of information. Okay? Now, they want the dimensions of the printed area. So guys, the printed area is going to be this right here. This is the printed area. To be 24 inches squared. The rest of the paper is non-printed area. So they're saying we're going to give you some kind of piece of paper, but whatever you do, you have to give us 24 square inches of printed area. Now, if you can optimize that, your red area right there, what size does the whole paper have to be so that that little rectangle is using the most amount of paper without breaking the rules? That's what they're basically saying. Like how are you going to do this? So let me start this up. Like I said, I'm going to give you a picture. Okay? So to figure out the 24 square inches right there, you see a little rectangular thing. That's area, right? So what's area of a rectangle? Length times width. I'm going to call it x times y, okay? X times y. Now those little edges right there, those margins, I know this is supposed to be 1.5 and 1.5 because they told me that the left and right margins should be 1.5 each, right? And then on the height, this should be a 1 and this should be a 1. You guys follow me so far? So now they say, okay, now that you know this information, do it, right? Oh, great, thanks, I get to do it. So what am I going to do? What equations can I create based on what I see? I kind of gave you one by saying some stuff earlier about the rectangle's area, right? What's the area for that red rectangle? X times y equals what? What's x times y equal to? 24, right? Now, the other area is the area of the big paper, right? We have the area of the big paper. What's the formula for the area of the big paper? So what's this distance here? That's y plus 2. What's this distance here? X plus 3. So what's the area of the big paper? Go ahead. I'm hearing you. Y plus 2. There you go. All right. So there you go. I got two equations. All right. What am I optimizing? Is it the left equation or the right equation? Now read this right here. What are we trying to use the least amount of? Of the whole paper. So what am I optimizing? Left equation or right equation? The right equation, because that's the whole paper, right? The x plus 3, the y plus 2, that's everything. Okay? Now, that means if I'm optimizing the whole paper, I'm going to take a derivative of it, right? I'm going to optimize my area. But how many variables do I have for area? 3. Can't have that. So what do you think the left side equation is going to be for? I'm going to solve for either x or y, right? And then I'm going to plug it in. So let's just solve for x. Okay, let's solve for x. So x is equal to 24 over y. And I'm going to plug that in to my a equation. So a equals to y plus 2 times 24 over y plus 3. And what I'm going to do is something that you may not want to do, but we're going to do it anyway. We're going to distribute this out. Okay? We're going to distribute this whole thing out. So let's see. Because I don't want to do a product rule with this. I don't know about you guys. I'd rather just distribute it, get a bunch of little power rules, and be done with it, right? So y times 24 over y is just 24. Y times 3, 3y. 2 times 24 over y, that's 48 over y. And then 2 times 3, that's 6. So a is 30 plus 3y plus 48. You might say, oh, well, now I got to do a quotient rule. No, I don't. I got to write y to the negative 1, and now it's a power rule. You can do that stuff for little simple things. Okay, I don't have to do crazy quotient rules for everything. So guys, all we're going to do is I'm going to take the derivative of this, and then for homework tonight, I'm going to have you guys see if you can finish up the problem by figuring out your value for y and x, and then maybe giving me the whole thing. We'll come back tomorrow, and we'll go over it still, okay? But I'm going to see if you guys can do it. But let's take our derivative for a, because that's kind of what I got to do. I got to optimize, right? So dA d what? Y, right? Because that's what the variables are, y. So derivative of 30, that's 0, right? Now my derivative of, I'm trying to see here what I did. X plus 2. Did I, hold on, give me a second. What is the left and right margins? Oh, I did this stuff backwards, didn't I? I did, I just realized something. Because what my left and right margins are, according to the equation, 1 inch. I put 1.5. You know what? Instead of changing the whole problem, you guys mind if I do something? Instead of changing everything that we did, I'm going to erase up here, okay? That's less erasing for you guys. This would be 1. Let me highlight it. And I'm going to put 1.5. And I'll highlight that for you guys. Sorry about that. That'll change the whole problem, and we won't have to erase anything that we've written except for those two little things. Okay, so the margins on the sides are 1.5. Good. My picture shows that. Margins on top and bottom are 1. Good. My picture shows that. Okay, I apologize for that, but it's a simple little change, and we're back to it. Okay, so all right, so the derivative of 30 is 0. The derivative of 3, well, that's 3, right? And then the derivative of 48, y to the negative 1, that's going to be a negative 48, y to the negative 2. So dA dy is equal to 3 minus 48 over y squared. Now, if I can simplify that, well, actually, we don't have to, because all I have to do here is set it equal to 0, right? If I'm going to optimize it. So 3 minus 48 over y squared equals to 0. At this point, I'm going to stop, and you guys are going to solve for y, okay? And then tomorrow we'll talk about it.